this topic is about sketching exponential functions and labeling the key features such as asymptotes and intercepts with the axes. So again, there are two different cases that you can have. So the first case is when y is equal to a to the power of x, where a is greater than 1. Okay. Now what we do know is a to the power of x will always cross the y-axis at 0, 1. Okay. And also, there is an asymptote, so only one horizontal asymptote at y equals 0. So if we were to write out the key features of this graph, so first thing is there's a y-intercept at 0, 1. Since a to the power of 0 is always equal to 1 for all real numbers a. Also, there is an asymptote at y equals 0, which implies there are no x-intercepts. Okay, so those are the two features that you can clearly see. Also, as x tends to infinity, so as x gets very, very big, y also tends to positive infinity. So y is also getting very, very big. As you can see, it's getting steeper and steeper. And as x gets closer to negative infinity, so more and more negative, you can see y is getting closer and closer to 0, but it never reaches it. So that would be that part. Okay, now obviously there's a second case. So I draw that here. So y is equal to a to the power of x when a lies between 0 and 1. So when a lies between 0 and 1, you get a very similar graph, but it's reflected. So it starts off getting closer and closer to 0 on this part, and then steep here. So again, it does go through 0, 1, and there is an asymptote at y equals 0. So if I again were to write the key features of this graph out, y-intercept at 0, 1 still. The asymptote is still at y equals 0. There are still no x-intercepts. The difference being this part, which is as x tends to infinity, you can see y gets closer and closer to 0. And this is because this is a number, a very small number between 0 and 1. So if you take a really small number between 0 and 1 and you raise it to a positive power, this number is going to get smaller and smaller. And that's why it's getting smaller and smaller and smaller, getting closer and closer to 0. As x tends to negative infinity, y tends to infinity. Now that is because you've got a very small number and you're raising it to a negative power. As you're raising it to a negative power, it gets bigger and bigger, because a very small number raised to a negative power gets bigger and bigger. So that would be it. Now, just also looking at these cases, so if I had to sketch y is equal to 2 to the x, y is equal to 3 to the x, and y is equal to a quarter to the x on the same graph. So if I do the first one, which is y is equal to 2 to the x, so again, if I'm drawing out, it's closer and closer to 0, goes through 1, and then steep, so 0, 1. So y is equal to 2 to the x. Asymptote is at y equals 0. If I draw now, sorry, let me just label it. So this is the green one, the red one. So next one would be green. So y is equal to 3 to the x. Because 3 is bigger than 2, it'll still have to go through 0, 1, but it will increase much rapidly. So it's going to be very steep here. Again here, because it's raised by negative power, it's going to get smaller very much quicker, but again, it's approaching the same place. So y is equal to 3 to the x. Again, y is equal to 0 is an asymptote, and it does still go through 0, 1. So the only difference is it's much steeper. If I have a quarter to the power of x, let's change that to a blue. Okay, a quarter is between 0 and 1, so I know it's going to be the opposite way around. Whoops. Undo. So it gets closer and closer to 0 in this part. And here, quarter, because 4, the denominator is bigger than 2 and 3, it will be much steeper than both this graph, but it doesn't matter. All we know it goes this way. So y is equal to a quarter to the power of x. Again, y equals 0 is still a asymptote. It does still go through 0, 1, but it will be a reflection of the other two. Okay, so just to keep in mind that if you're sketching 2 in one graph, then if the base is higher, then it will increase more rapidly. Let's look at some examples and questions. Okay, part A. Sketch the curve y is equal to 3 to the x and state the coordinates of any point where the curve crosses an axis. So if I were to sketch this, because 3 is bigger than 1, I know it's the first case. So I know it'll look like so. I need to label this as 0, 1. And there is an asymptote still at y equals 0. Although it doesn't say to state it, I would always write it down. Y is equal to 3 to the x. That would be that one. B, sketch the curve y is equal to half to the x. So because half is between 0 and 1, I know it's the second case. So if I were to sketch it, it's going this way. Again, labeling this point as 0, 1. Labeling the asymptote as y equals 0. And this is y is equal to half to the x. So that is it. So just recognizing which one you have in front of you, which case you have in front of you. Okay, next question. Sketch the graph of y is equal to 1 to the x. Now, y is equal to 1 to the x. 1 to the x is always equal to 1 for all x is the element of roots, because if you raise 1 to any number, you're always going to get 1, which means your graph will always give you an output of, this equation will always give you an output of 1, which means you're going to get a graph that goes through 0, 1. Whoops. It goes to 0, 1, but also is 1 for every x value, so it's going to be a straight line. So going through 0, 1. So y is equal to 1 to the x, it's just a straight line. Same thing as y is equal to 1. Okay. For each of these statements, describe whether it is true or false, justifying your answer, offering a counterexample. Okay, so A. The graph of y is equal to a to the power of x passes through 0, 1 for all positive real numbers A. Okay, is this true? Because if I substitute x equals 0, y equals 1 into, if I substitute just x equals 0, sorry, not x equals 0, and y equals 1 into y is equal to a to the x, I get y is equal to a to the power of 0. And I know a to the power of 0 is equal to 1 for all values of a is the element of real. Therefore, the graph will go through 0, 1 for all A is an element of reals that are positive. I should write true. Okay, B. The function f of x is equal to a to the x is always an increasing function for a greater than 0. So this is false, because increasing function means it's always going up. False because for a between 0 and 1, the function f of x is decreasing. E.g., when a is equal to a half. Okay, C. The graph of y is equal to a to the power of x, where a is a positive real number, never crosses the x-axis. So this is true because if it crosses x-axis, the x-axis, then y is equal to 0, which implies that 0 would be equal to a to the power of x. But we know that this cannot be true for any real value of a. So a to the power of x equal to 0 has no real solution, therefore it does not cross the x-axis. I should rewrite for a real positive value of x, because obviously it would be for a is equal to 0. Okay. Yeah. Next question. The graph of y is equal to ka to the power of x passes through a point 1, 6 and 448. Find the values of the constant k and a. So if I substitute 1, 6 into y is equal to ka to the power of x, then I get 6 is equal to ka to the power of 1. So I can leave it like that. Now if I substitute 448 into y is equal to ka to the power of x, then I get 48 is equal to ka to the power of 4. So this is equation 1. Equation 2, what I know is I've got k in both, so I can eliminate k by dividing. So if I do 2 divide by 1, because a to the power of 4 is bigger than a, so if I do that way around, then I end up getting 48 over 6 is equal to ka to the power of 4 over ka. So we eliminated k, which implies 48 divided by 6 is 8, must be equal to a to the power of 3, which means a must be equal to the cube root of 8, which implies a is equal to 2. Okay, I also need to find the value of k. So now that I know a is equal to 2, I can substitute a equal 2 into equation 1, which means I get 6 is equal to k times 2, which implies k is equal to 6 over 2, which means k is equal to 3. Okay, next question. The graph of y is equal to pq to the x passes through the points minus 3, 150 and 2, 0.048. A, by drawing a sketch of or otherwise explain why 0 is less than k, which is less than 1. If I sketch it out, okay, so I've got minus 3, 150, so minus 3 somewhere here, 150 is somewhere there, so that is, let's just say, minus 3, 150. We know it's in the second quadrant. And 2, 0.048, 2, 0. Somewhere in the, oops, that's not right. Somewhere 2, 0.048 is both x and y are positive, so it's somewhere here in the first quadrant. 2, 0.048. Okay, because I know this is decreasing, so it's exponential graph, oops. Goes to, let's say, 0, 1, because it's exponential graph. Then because y is decreasing, then q must be between 0 and 1, so the base of the equation, exponential graph, so 0, it must be between 0 and 1. Okay, part B, find the values of the constant p and q. The first thing I need to do is substitute minus 3, 150 into y is equal to pq to the power of x, which means I get 150 is equal to pq to the minus 3. That's my equation 1. I also need to substitute 0.048 into this equation. So I end up getting 0.048 is equal to pq squared. Again, I notice I can eliminate p in both of them, and I might as well do 2 divided by 1. So I end up getting a q to the positive power. So I end up getting 0.048 over 150 is equal to pq squared over pq to the negative 3. So the p's cancel out. Now do this division. I end up getting 1 over 3,125 in my calculator is equal to q squared divided by q to the minus 3, which is q to the power of 5. Okay, which means q must be the fifth root of 1 over 3,125, which ends up giving me q is equal to 1 over 5. So I found q, now I need to find p. So substitute q is equal to 1 over 5 into, I'll do it into equation 2. Then I end up getting 0.048 is equal to p times a fifth squared. If I do, p must be then equal to 0.048 divided by a fifth squared, which ends up being 6 over 5. So my solutions are q is equal to a fifth and p is equal to 6 over 5. Okay, next question. Sketch the graph of y is equal to 2 to the power of x minus 2 plus 5. Give the coordinates of the points where the graph crosses the y-axis. Okay, so if I work out first the y-intercept, it's when x is equal to 0, so it implies y is equal to 2 to the 0 minus 2 plus 5, which means y is equal to 2 to the minus 2 plus 5, which means y is equal to a quarter plus 5, which is 5 and a quarter, which you can write as 21 over 4. Okay, if I want to find the x-intercept, it means y equals 0, which implies 2 to the power of x minus 2 plus 5 is equal to 0, which means 2 to the power of x minus 2 is equal to negative 5. Now, 2 to the power of anything giving you negative 5, you won't get any input that gives you negative 5. Therefore, no solutions. No solution. Therefore, no x-intercept, which implies y equals 0 is an asymptote. So if I'm sketching this, so it's 5.25, which is 21/4, is the y-intercept. Okay, we don't have an x-intercept, so y equals 0 is an asymptote. So we know because it's 2 to the power of is the first case, so it's going to look something like that. So y is equal to 2 to the power of x minus 2 plus 5. Okay, last question, then we're going to go through sketch y is equal to 2 to the power of x plus 4 and y is equal to 3 to the power of x on the same axis. So for y is equal to 2 to the power of x plus 4, so y is equal to 2 to the power of x plus 4. So the y-intercept is x is equal to 0, which implies y is equal to 2 to the power of 0 plus 4, which is equal to 2 to the power of 4, which is 16. So it goes through 16. The x-intercept, because x-intercept, well, let's just do it anyway. X-intercept means y is equal to 0, which means 2 to the power of x plus 4 is equal to 0, which has no solution, which means y is equal to 0 is an asymptote because it's undefined when y equals 0. So y equals 0. It goes through 16. So 0, 16. Let's do like this. And we know because it's if the first case, it's going to look something like this. So y is equal to 2 to the power of x plus 4. Okay, let's look at the second one, which is y is equal to 3 to the power of x. Y is equal to 3 to the power of x. Now this is just a normal exponential function, which means it's going to be the first case, which means it goes through 0, 1. Okay, now it's obviously below the red graph, which is 2 to the power of x plus 4, but because the base 3 is bigger than the base 2, eventually, at some point, it'll overtake the red graph, okay? So that's what you need to realize, it's going to overtake it, and that would be it. And these two graphs are getting closer and closer to 0, so both of these. The key part is that you draw in the fact that it eventually overtakes it. And that is it. Also for the, y is equal to 3 to the power of x graph, the asymptote is still y equals 0. And that's that.